Hello everyone, welcome to my new science school chemistry class. In this class we are going to discuss these terms. First we have atom, molecule and ion. And in the course of this lesson we will also discuss element, because element is somehow related to atom. Okay. When we say atom, as we said in our previous videos, we said that atom is the smallest particle of an element. So this definition of atom, we can copy it. Is the smallest particle of an element. Is the smallest particle of an element. Is the smallest particle of an element. That means if you have an element, then the smallest particle of this element is termed atom. For example, let's say we have a rod. Let's say this is okay, let's draw it like this. You have something like this is a metal object. So this metal is made up of very tiny particles. Those particles are atoms, because before we reach to this level we have very tiny particles that their aggregation they made of this rod. Then if you are talking about this particular particle, or this tiny particle is an atom. We explained this in details in our previous video. If you need details about what is atom, you can go back to the previous video and watch. Now we know that atom is the smallest particle of any element. Remember, this is ion. This is ion. So this is ion. We have similar material, which can this material could be, let's say, silver. This could be silver. We have something again that could be copper. Copper, silver and iron are different material. Iron is different from silver. Silver is different from copper. Both of them are different things. So we have iron as an entity, silver and copper too as entities. But when we are talking about these elements or these materials, you can refer to specific or one dot, or those tiny pieces, those tiny atoms that made of this what do you call this rod, iron rod. So this tiny particle, this little dot that we use, or that were aggregated to make the rod, they are called atom. We explained this in details in our previous videos, as I said. So now we can see that this atom or this particle is an ion itself. It's an ion. Since it is an ion, then even if you have them, let's say 10 of them, they are all called ion atoms. Single is ion. 10, 100 and thousands, all are ions. So now we refer to this ion as one of the element. So element is just referring to the type of atom or atoms. Element can be single atom. A single atom can represent a element. This single atom, you must call it ion atom. You must say it is ion. That's saying it is ion, then it is automatically element. so it is element. And if you have thousands of these dots or trillions of them, then you still have ion atoms. Now you can have single, just like people. Now if you have a single person, you have human being. If you have 10 of them, then you still have human beings. So saying human beings, species of human beings, then you are referring to that particular type of organism. And still, in the other hand, if you have like cows or goats, single goat can represent the species. Multiple thousand or hundred of them can also represent or can also bear the name goat, just that it is plural and singular. So if you are talking about atom and element, it's just about general term for both singular and plural. Single is atom and is still element, because if somebody asks you, is this copper atom? No, you will say no, it is iron. So this saying it is iron atom, then you are telling me that it is iron element, because it's the element that can be that is formed from the atom. Atom is just pointing at single particle within the element. So just like you find table salt. This is, let's say this is a, let me use it as spoon, or this is container used to carry salt, and this is the salt. And in the salt now you have many particles. This name salt is just like you are naming the types of material or the types of this substance. This substance is what? Salt. Does that mean if you take only single particle of this salt, cannot be called salt again? No, this can be called particle, but particle of what? Particle of salt. So now this can represent, this can be called salt. All of this can be called salt, but there are thousands of these particles, many of them, that make up this whole salt. So now in case of atom, this single particle that made of this single particle that is that 2, 3, 4 thousands of them make up the ion that we can see and touch. Because of their number, then we still call them element. Single is element, but now is at atomic level. Multiple or thousands of them, they are still element, but now they are much more, or there are many more atoms that you can handle. So element and atom are almost the same, but when you say element, it's just the general name, while atom, you are pointing, you are just considering, or you are just dealing the, or you are just working at the level of the particle of the element itself. That is the important thing that you want to, or you need to note. So if you are dealing with element, then now people will just, yes, you are not talking about atom, then you are not at atomic level. But when you are talking of atom, then within the element, we just pick one particle from the element. So that's the little explanation, or the difference between element and atom. Element is general term that could be single atom, 2 atoms, 3 atoms, 100,000, trillions, the whole heavy metal. That is just atom. That is just element. But when you talk about atom, then now we are referring to single particle within the element. So this is atom. Atom is the smallest particle of an element. Then the single particle, or the smallest possible particle of an element, is called atom, which can take part in a chemical reaction. What that means is that when we say that can take part in chemical reaction, is just let's continue with this. Let me explain it using this salt. When you take this single dot of salt here, you take it away, or you take it out. This single salt, if you taste this single salt, it will still taste as salt, but of course the concentration will be very low. But this single dot is still salt. If you taste, it's still salt, and if you check the color, it's still white, just as this, or just how this behave. The same way this particle behave, but of course will be of very low concentration. That's only different. So a single atom, when we define atom as a smallest particle of an element that can take part in a chemical reaction, that taking part in a chemical reaction is that if this can catch fire, when you have this salt, for example, can catch fire, this small particle can also catch fire, even though a salt are not a salt doesn't catch fire. So salt has taste. That chemical property of tasting salt, this particle will still have the property. If we take example of another particle, let's say petroleum, let's just assume something that can catch fire, like petroleum. You have petroleum in liter, for example. Yes, you have this. We have this in liter, for example, this petrol in liter. If you have single atom of this petrol, it will behave exactly as the whole content of this liter if it were petrol, because this single particle can catch fire or will catch fire. That means it is petrol. So if you want to taste petrol, if you want to see if this petrol is good or not, just take single atom of it out. If you can, then test the single atom. That will represent the all other atom. So chemical property of an element can be tested using the single atom of that element, depending on the reaction. Maybe sometimes the reaction will require more than one atom. That's why in chemistry we are not everything will be taken in the sense of at the level of atom or molecule. We always consider the atom or molecule. Now if you want to write hydrogen, we know hydrogen is gas that can be put in cylinder. That hydrogen in cylinder is too much for chemists to be practicing on it, or for you to write formula, we are not dealing with the whole cylinder. We are just or we always consider the atom of the hydrogen, because we know that atom will represent the whole, or we can have, or their single atom of hydrogen will have all the chemical property of that hydrogen. So we always deal with the atom. So that's the smallest particle of an element and chemical property that can take part in chemical reaction. If you want to do chemical reaction, if you want to know if hydrogen gas can catch fire, then you can use the atom. Unfortunately, atoms are extremely small, very tiny. You cannot do your experiment with atom. You must use something in larger amount, but still we consider our experiment, everything at the atomic level. We always consider the atom. For example, if you have let me say you have two let me use volume now. 2 liters of oxygen. Let's say 2 liters of oxygen used to burn 3 liters of petrol. So now for oxygen we wrote O2. Then for the petrol, let me say butane gas, not petrol. C okay, C4H10, C4H10 for butane. Now reaction between oxygen and butane in this example says that 2 liters of oxygen will need 3 liters of butane, or will burn 3 liters of butane. So that means molecules of this, that single one molecule of this oxygen will need 3 molecules of butane. So now we understand that the proportion of atom, the number of atom in hydrogen, I mean 1 atom of hydrogen will need 3 atoms of what? Let me just put it as molecules, since it is a lot of number. There's a lot of atom there. So 2 molecules, 1 molecule will need 3 molecules. That's just the explanation. 2 to 3 is just like, okay, it's 2 to 3. 2 to 3. 2 need 3. So you can say 3 molecule need 4. You'll understand this very well when we come to when we start chemical combination. So now let's define molecule. Definition of molecule is that molecule. So molecule is the smallest particle of substance. Remember, in defining atom we said is the smallest particle of an element. You have an element, but this time around is substance. Is the smallest particle of a substance. The smallest particle of a substance, which can normally exist alone and still retain the chemical properties of that substance. What I want you to understand here is that the definition and the concept is almost like is for the atom. We said here, if you have this particle of salt, this particle of salt will test, or all will represent salt. Like if you want to test salt, if you want to know what salt is, then use this particle if you could. If you can use this particle to test the properties of salt, then you will observe all the properties of that salt. If you test it, it will be salty. If you put it in water, it will melt. If you put it in if you observe the color will be white. So this particle is representing the salt. That's what we did for the iron. We said that single particle of iron will represent, or will have all the properties of iron, will represent, in fact, the characteristic of iron is all from the individual particle. The characteristic of individual particle give the iron its own characteristic, because this same particle, it's just repetition of this particle, or accumulation of similar particle, same particle, but thousands of them. They end up making the rod, iron rod. So if you want to test iron, you can use that single particle will represent the rest of the particles. So this is iron. When we say iron, we mean when we say element, we mean this particle that make up that make element. These particles that make element, they are all single particles. So in our case, this ion is made up of this particle, but they are all ion particles. In chemical reaction, you will have this particle from ion and this particle, let's say another particle here from oxygen, will meet and form something that will also be different substance. Let's say this is oxygen and this is what? Ion. Now you have entirely different substance. This substance now, if you have similar particle, let's say you have another ion, you have another what? Oxygen. You have ion, you have oxygen. Remember, this is what? Is now single particle coming from two different atoms. Here is another particle, here is another particle. These particles are not connected, they are individual particles. They are not connected, they are individual particles. Just as the way we can take one particle from this ion and serve as that we call atom and can have the all properties of the ion, then this newly formed substance, now you can use this pair, that atoms, that combination of or just this particle that is coming from two different elements, oxygen and ion. You can use it also the same way you can use this particle that made this iron rod. So you can have substance, let's say very big substance, but now this substance, it is not made up of an atom. It is not made up of same atom. It is made up of what? Iron atom and hydrogen atom. Is a substance, but now if you go to the unit particle within this substance, they are pair of two different atoms from oxygen and iron. They are chemically bound together. That means these particles are there acting as a single particle, but the particle is made up of what? Two different atoms. When you have this situation, then you have what is called molecule. Molecule is the smallest particle of a substance. Let's say this substance is called iron oxide, or let me just call it rust. This is rust. And now you can tell me rust is not an element. Rust is not an element. Why? Because for you to define element, you need to know that the substance that you want to call element must have its own atom that are purely, or that are single atom, that are all the same. This atom, let's say all these particles are similar and are coming from what? The same particle. What I mean, all these particles should be equal or should be the same. Then if you have homogeneous atom or homogeneous atoms, then that is an element. But when you have atom, or when you have particles that are not purely single atom, then this what they are going to make will be anything but not element. So element contains pure atoms that are identical, all of them, but molecule or other substance other than atom, they contain atom that combine with other atom to form something different. This unit is called molecule. You have many of them, thousands of them, trillions of them, then you have a substance. So in chemical reaction to produce a new substance, this is what is there in the part at the level of molecule. This is what you are going to see. If you are talking of water now, water is not an element, but is what is a substance. Why? Because water contains 1 molecule of oxygen plus 2 molecules of hydrogen. That is water. And these types of particles, thousands of them, many of them, you have what? You have water that we drink, we use every day. At the molecular level, this is what is there. So they cannot be called atom, or water cannot be called element. So that is the what do you call it? Molecule. Molecule is the smallest particle of substance which can normally exist alone. So this particle that we see can exist alone. It cannot exist alone. This particle can exist alone. Just that you have water, because these particles are many, too much of them, or many of them together, then you have water. But you can, if you decide, let's say you have this particle, all of them are particles that are made up of water. You can divide them into two and take some and go away with them. There is no any resistance that will not allow you to take a half of the, because they are free. All the particles can go about anyway. What will stop this particle is just container. That's why water must be in container. But there are some substances that are very hard, because there is force that binds this molecule together. But the molecule, they are acting as unit, just the way atom acts, but this unit contain more than one atom. That's just the definition. That's why when we are talking of other element, something like hydrogen, if you have particles of hydrogen, as we explained yesterday, that this hydrogen contains single electron here due to the single presence of vacant space for the next electron, because this shell need to complete the outermost shell. It will always need another electron so that it will fill the outermost shell. That's why oxygen atom will never stay alone. It must go and meet another atom of hydrogen so that they will form a bond that is called covalent bond. This covalent bond is just sharing of electron. As we said, the rule is just when you are moving on this shell, you must meet 2 electrons. This is the requirement for this shell. This is what we have: first electron, second electron. Now you fulfill the requirement. In case of this is gaining of electron. In case of nowhere to get this electron to do this, or to give hydrogen, or hydrogen has there's no any other atom to accept this electron if it were only one atom, or if it is only one, let's say you have only one electron in the outermost shell, and there is no any other atom that will receive this electron to free or to make this shell empty, so that this atom of hydrogen will just remain the proton, and it will be a hydrogen ion, which is called proton. If there is no atom to receive this electron, what will happen is that this electron, that is this hydrogen that is here, because hydrogen, this is just hydrogen, neutral hydrogen, but hydrogen is gas, and at the atomic level we have many of these hydrogen atoms. So what they do, they just come together and form what is called covalent bond. This covalent bond is characterized by sharing of electron. How sharing of electron works, as we mentioned earlier, this hydrogen can lose electron or can gain electron to either to free or to remove this shell, so that it will remain only proton to become hydrogen ion, or it can gain electron. This is how it is before. It can gain electron so that it will fill this outermost shell, so that if you are counting from here, you will meet one electron here, you will meet another electron here, then this shell is complete. In the case of no electron to receive and no atom to accept that electron, then this hydrogen these hydrogen molecules that are there in the container, they will arrange themselves into two. This atom will just come and meet this atom, and they do something like this. Let me draw it somewhere here. You have hydrogen atom with the nucleus, and you have hydrogen, and you have electron. Let me put electron here. This electron. Then another hydrogen atom will come, and just let's draw it like this. We just come here and put it and they will just come close to this the first hydrogen atom. Then this second hydrogen atom, this one, will bring its electron here, so that they share the electron. Because the essence of this is that when you are counting how many electrons are there in the outermost shell of this hydrogen, if you start from this one, you are counting no electron. Here you have one, here you have two. Then this one is complete now, because it is having two electrons at the outermost shell, or in the outermost shell. The same thing with this atom. When you are counting, when you come here, you count the electrons that was for this atom before, and the next electron, or the electron that was for this electron. So you have the sharing of electron. They will just share the electron on or of the outermost shell, so that they will complete their what they call doublet state. So you have doublet state for this electron, for this atom, and doublet state for the other atom. So this is what they do. So if you have thousands of them, they will just arrange them, they will just pair themselves into two. Then you have 500 groups, or 500 pairs. These pairs are called molecule. So molecule can be formed by a single element. hydrogen element can form molecules that is called hydrogen molecule. Oxygen molecule means combination of different is the pairing of a hydrogen molecule. Oxygen molecules is formed when two atoms of hydrogen paired up and shared electron. So hydrogen atom 2, let's say oxygen, sorry, let's say this is the outermost shell, this is nucleus, this is outermost shell, oh sorry, innermost shell, this is outermost shell for oxygen. This is 2, we have 2 here, we have 1 2 3 4, this is 4. Oxygen has 6, so we have here, we have here, okay, 1 2 3 4 5 6, so you have 6 here. What will happen is that this electron will come here, will come here, and next hydrogen atom will be like this. Just draw the shell here. Just draw the shell here. This is the center, this is the innermost this innermost shell with 2 electrons. Then you have 1 2 1 2. Then the next 2 electrons, since there are 6, they will put here, here and here. Then if you are counting for this one now, if you start from here, then you have 1 2, okay, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8. Now the outermost shell is 8. That's what it wants. You have 8 at the in the outermost shell. Still, if you are counting for this atom 2, you will have 8. We have 1 2 3 4 5 6 7 8. This is also 8 electrons in the outermost shell. That forms hydrogen molecule. You have, oh sorry, oxygen molecule. That's why we write oxygen 2. What is the meaning of this 2? It's telling you that this hydrogen is in group of 2s. That's why we write 2. Some molecules, before they form their some of the molecules, some atom, for them to form molecules, they need more than 2 atoms. Like nitrogen will have 3 atoms together to make molecules. That's why we have M2. Yes, we have N2, we have N3, a lot of different combinations, but we are going to look at that in our next class. So now we know what is molecule. Molecule can be from different atoms. Molecule can be from same atom. So same atom will pair or will become in 2s or sometimes in 3s to make what is called molecules. And that pair of this atom can exist alone, can fly away, or can follow air, a lot of things. This single pair can go anywhere, is independent. So that is what, and if you want to test this substance, just use this, just use the pair. The way you use particle of salt to test or to know about salt, then you can use single pair of molecule. You can use molecule to also know the property of a substance. So that is another a very important thing for us to note. So any substance that you see in this world has its own molecular particle. If we are talking of petrol, for petrol, for petrol, it is let's say this gas butane. For butane is C4H10 as we wrote earlier. So this is a molecule of butane, and thousands of similar particles like this. Let's say this is a particle of butane. This particle of butane is made of by 4 C's. We have C, 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 and we have hydrogen everywhere. Hydrogen, 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 hydrogen. This is 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 hydrogen. 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 You have 10 hydrogens surrounding or connected to 4 carbon atoms. So this is molecules of what? Butane. So you have this as a molecule. So if you want to know what is butane, just do your experiment with only these particles. And these particles, thousands, millions, trillions of them made of what? The gas we know as butane. So at molecular level, these are the atoms that are made of butane, hydrogen, and carbon. So if somebody asks you what is the difference between atom and molecule, the simple difference is that atom is the smallest particle of an element, while molecule is the smallest particle of a substance. That substance, the word substance can be element in case of hydrogen and hydrogen, because we have only single element, hydrogen and hydrogen, or other sort of combination, because we have homogeneous and we have heterogeneous. When we say homogeneous, we mean same particle made of the molecule. Heterogeneous means different particles, I mean different atoms from the molecules. So heterogeneous, this is homogeneous, and hetero. When you hear hetero, that means different. Heterogeneous, that means different particles. So heterogeneous atoms, then homogeneous atom and heterogeneous atom. Homogeneous means the same or similar atoms, while heterogeneous means different atom. So you can have molecule that is from single or same molecules that are from hydrogen atoms, and molecules that are from hydrogen and iron. So hydrogen and iron will fall under heterogeneous, while only hydrogen are under heterogeneous. But what is that molecule? Is just a particle, a smallest particle of substance that contain more than one atom, while atom is a particle of a substance that is what? Only one atom. That's the main difference between the two. Now the last one is, we talked about atom and molecule. The last one is ion. We talked about ion yesterday, or in our previous class. We said that ion, whenever we have atom, when this atom, let's say this is hydrogen, when this atom gain or lose electron, then we produce ion. If this hydrogen is like that or like this that you see, it's just hydrogen. But when you add electron to this hydrogen, then you make it to be 2 electrons, but you do not add any proton here, you will have additional negative charge. Instead of it to be neutral, now you make it to be negative. So ion, it just means that there are imbalance of charge between the nucleus and the shells. Next thing is when this hydrogen loses the electron entirely. This is the electron. When this electron is ripped off by some of the element that always need electron, or that will always need electron, then this hydrogen atom will lose the electron and the outermost shell. Then it will end up having only the proton at the center. That proton is a positive charge. Then you have hydrogen plus. This is ion. So the difference between ion and atom is just that the ion, there's imbalance charges between the nucleus and the shells of an atom that will produce charge, and that could happen only when there is gaining or losing of electron without affecting the nuclear particles, which are proton. So I hope I explained this the way people understand it. By this, I come to the end of this class. As always, if you enjoy our lesson, please like, comment, share, and subscribe. Open your notification button so that you will get subsequent notification for subsequent lecture. And if you want to join our WhatsApp group is waiting, or WhatsApp class is waiting for you. Just use this number 081 28 14 18 16. Talk to us on WhatsApp. And still, if you want to ask a question, you can do so by putting it in the comment section, or email us at mynewscienceschool@gmail.com. Thank you for watching. Hope you enjoyed the video. My new science school, as always, we wish you success. See you in the next lesson.